In this lesson, we're talking about division properties of exponents. So we've talked a lot about multiplication properties of exponents, but what happens when the opposite is happening, right? What happens when we're dividing instead of multiplying? Well, guess what? I gave it away when we're doing the opposite. So we're going to do the opposite procedures. So if we look at the rule here, right, when we have the same base being divided by something with the same base, what you're going to do, instead of adding, you're going to say m, so whatever that exponent is, minus the other exponent. Okay, so when we're multiplying, then you added the exponent values. But when we're dividing, you're doing the opposite. You're going to subtract them. Okay, and I know this example shows this from moving the denominator to the numerator. But this works. You can actually do it either way, and whichever one is larger. So for example, over here, we're going to see an example here where 2 and 3, right, same bases. Well, 3 is a larger power, so we would actually move that m to the second power to the denominator. Okay, we can see our example with numbers 2, so 3 to the 6th power over 3 to the 2nd power, right? 6 minus 2 equals 3 to the 4th power. Okay, so let's see. So some problems you might see. This is an example. So 4 to the 7th power over 4 to the 3rd power equals 4 to the blank power. Okay, so it's already giving it, reminding you that, hey, the base is going to remain the same when we're working with these rules. The base remains the same. Okay, so we're going to say, well, 7 minus 3. 7 minus 3 is 4. Now, number 2, we see a lot of them. So I see, okay, 4 to the 3rd power, 4 to the negative 2nd. I see m to the 2nd, m to the 3rd, n to the 4th, n to the negative 2nd. So a lot of similar bases. So these are going to combine. And I think since I have this negative, this is going to go up. And right, remember, I can put this into the denominator to be positive, if you remember your rules with negative exponents. But let's look. So when we're dividing, I can do this. 4, 3 minus negative 2, which we know our rules with subtraction, that's actually going to be addition, right? We're going to add 2. Over here, I told you that when they have the same bases, one of them has a larger exponent, you're going to want to move them to the one with the larger exponent. So n to the 2nd, n to the 3rd. n to the 3rd, that has a larger exponent value. That's a larger power. So we're going to leave that in the denominator and do 3 minus 2. And then here, n to the 4th power, n to the negative 2nd. Well, 4th power is larger, so I'm going to do n to the 4th power minus negative 2. Let's see what it gets me. 3 minus negative 2 is 5, positive 5. So 4 to the 5th power, I get n, and it's 4 minus negative 2. Well, that's 4 plus 2, so that's n to the 6th power. And then down here, m to the 3rd minus 2. 3 minus 2 is 1, so it's just m. Now, as long as you follow these rules, it's going to work. Okay? You could, let's pretend that you had subtracted, you tried to move this to your numerator, you did 2 minus 3, you would have gotten n to the negative 1st power. Well, that's still going to help you get the correct answer, because from there you can say, I don't want a negative exponent, and you can move your m to the denominator. So if you ever end up with a negative exponent in one of your values, right, in one of your powers, you might not have done anything wrong. You just maybe moved it to the numerator or the denominator when you should have done the opposite. So you can use the rules you've learned to fix that. Okay? Alrighty. For this one, for number 3, what you're going to do is that negative power needs to go. It needs to go to every value, right? So that negative 4 needs to go to that 2. So it needs to be 2 to the negative 4th. That negative 4 needs to go to that m to the 5th. Okay, so it needs to be m to the negative 20th. This negative 4 needs to go to the m to the 2nd. Okay, and that's going to become m to the negative 8th. So remember what I told you about you want to send the smaller value, in the smaller power, to the larger power. Guess what? M to the negative 20th is a smaller power than m to the negative 8th. right? So that's going to get us to, let's do 2 to the negative 4th. We won't simplify that yet, but we're going to move the m to the denominator. So I'm going to negative 8 minus negative 20. Okay? And that's going to get us to 2 to the negative 4th. It's going to be m to the, well, that's really negative 8 plus 12, or sorry, plus 20, which is positive 12, m to the 12th. But then I don't want a negative exponent, so it's going to end up being 1 over 2 to the 4th power, m to the 12th power. Okay? And then for example 4, this is working with division when we're working with scientific notation. Okay? So what we need to do is we need to take our coefficients out here, right, these values, and we need to say 8.4 divided by 2.1. Well, that's going to get us to 4. Okay? Then we need to look at 10 to the negative 8th, 10 to the 4th. Remember, with scientific notation, we don't actually want anything in the denominator. We need this to not be a fraction. So we are going to move this up. Even though this would be larger than negative 8, I need everything in my numerator. Okay? So I'm going to get 10 to the negative 8th, and the rule is, right, when I'm moving it, I'm moving that 4 up, so I need to subtract 4. And that's going to get me to 4 times 10 to the negative 12. Okay? And I need to look at it, and I say, is this in scientific notation? What I need to say, I need to look at, is this between, right, does this fit this rule? That it's 1 is less than or equal to the value there, right? Which is less than 10. Yes, this is between 1 and 10. Okay, 4 is between 1 and 10. And then over here, we see that we have 10 to the negative 12th. That's good. It's the base of 10 to some exponent. It can be positive or negative. Things we need to remember. Okay, there cannot be a fraction. We don't work with fractions in scientific notation. So if you have a fraction, you need to turn that fraction into a decimal and then make sure that that decimal is turned into a number that's between 1 and 10. And remember, it could equal 1, but it cannot equal 10.